This episode is sponsored by Raycon. The galaxy is a big place, a billion kilometers across. So if anyone was out there trying to talk to us, a signal would be very faint. So how would they go about boosting the transmission? So today we return to the Alien Civilization series to look at the notion of talkative aliens, aliens who actually wish to speak with us, as well as the general notion of interstellar communication. We'll be considering the available options under known physics, but also discussing some of the more theoretical scenarios like faster-than-light communication. We're also teaming up today with Alberto Caballero, host of the Exoplanets channel, and Parallax Nick, who will be looking at optical and laser SETI in parts 2 and 3. They'll explore how we might use lasers to talk to aliens and how we might detect them if they were trying to chat with us, as well as why this is probably the most promising way to search for aliens. If you're not already subscribed to their shows, make sure to give them a like and a subscribe when you head over for parts 2 and 3. Also, since this is a 3-parter, we'll be here for a bit, so now is a great time for a drink and a snack. SETI is the acronym for the Search for Extra-Terrestrial Intelligence, a collective term for several loosely affiliated scientific efforts. There is a prominent group called the SETI Institute that is very well known for their SETI work, but there are also several other groups involved in the search under their own auspices, and strictly speaking, though the name implies SETI only includes searches for intelligent life, we do often use it to refer to hunting astronomically for any signs of any alien life, including for atmospheric traces of oxygen-breathing microbes on exoplanets. SETI would also include looking for intentional signals sent to us, and general background signals of them talking to each other, as well as other telltales like the infrared waste heat of Dyson swarms. It can also include active SETI or METI, messaging extraterrestrial intelligences, which is where we send messages out hoping for a reply, and that is our main focus for part 1. This could be by current technologies like radio waves or lasers, or with more futuristic options like flashing a star to emit a signal, or using some unknown method of faster-than-light communication. It is important to think outside the box when searching for extraterrestrial intelligence, because thus far, after decades of searching the most obvious method of radio transmission, we have still come up with nothing. At least that's the method most obvious to us, but that raises a key question of how they would communicate. Now we tend to assume it would be by their own preferred mode of communication, and of course if we're discussing talkative aliens in the sense of them just talking a lot, then that makes sense and we have to consider alternatives to classic omnidirectional signaling, including those outside known physics like FTL communication. However, if we're saying talkative in the context of wanting to talk to us specifically, or more broadly some relatively young species lacking an interstellar presence, then we probably shouldn't assume they are employing their standard method of communication in favor of what they think we would receive. If you want to talk to an uncontacted tribe in the Amazon, you don't use radios, let alone trying to message them on Facebook or hunting for their phone number or email address. If we were to assume they were trying to reach us by radio, it implies one of 3 things. First, that might just be how they communicate still too, that is the best method available to them. Electromagnetic waves are the fastest thing we have, and science fiction aside, there really is no reason to think anyone could ever do better. Quite to the contrary, I personally don't expect anyone will ever figure out a way to send messages or traffic inside our universe faster than light, and so light-based transmission, be it radio or laser or some other type of beacon, might be the best they've got. The second option is that is the best they have for talking to us. They might have some better methods for communicating among themselves that they doubt we could hear, like FTL messages and tachyons, but perhaps they don't have FTL travel or the desire or capacity to send ships or probes. The third is that it is the best method they are willing to try or can be bothered to try, which is to say they could land here or throw a radio link through a wormhole into Earth's orbit, but they don't want to talk to people beneath a certain technological capacity, either feeling it unethical in some equivalent to the Star Trek Prime Directive, or simply not valuing that contact. From one perspective, an advanced civilization isn't going to learn much by chatting with us, and might not value our art or culture beyond a minor academic interest, and is just content to get the details of our more primitive periods from our own historical records down the road. They only want to talk to us once we reach a certain point, and there's a communication method we don't know yet which folks generally discover when they get to about that point. In Star Trek, for instance, they don't talk to pre-warp civilizations, and it's implied not really because they think discovering warp somehow makes folks magically ready for chat, so much as it's unavoidable they discover other civilizations at that point anyway, and are as ready as they're gonna get at that point. There might be some equivalent to galactic internet running on FTL ions, and as soon as you discover those, you discover Galactronet, and they just wait till then. So it might be one of those three or some combination of the three, like it's hard and expensive to talk to us by one method, and they figure an extra century of waiting to talk, set against all the signal lag time and endless millennia of evolution, isn't worth the cost and effort. They also might not exist or be trying to hide, or just wait for signals then send in warships, not the diplomats. We've examined those options before in this series though, and for today, we're focused on folks who want to talk to us. Using those assumptions and three scenarios, we should ask why it is not radio, since clearly no one is pumping out very loud radio messages. This of course depends a lot on their technology and resources. I generally tend to assume no FTL or laws of thermodynamics and energy conservation violating technologies on this channel when discussing our potential future as an interplanetary or interstellar species, and if you've got those it only makes things easier, and if you're a show regular, you know the sorts of titanic resources available even to K2 civilization, one with access to most or all of its sun's energy output, usually via a Dyson swarm, let alone the capabilities of those who have gone interstellar. Science fiction tends to discuss K2 civilizations as vastly far ahead in time, but realistically you probably hit K2 status before your interstellar colonies represent even 1% of your population. That's because K2 is not a population size or technology level, it's just access to most of your sun's power, and you can achieve that by basically wrapping it in thin sheets of reflective aluminum foil. And that's exactly the sort of repetitive, simple grunt work even the simplest of clanking replicators can do. This is basically a robot or short chain of robots that can make copies of themselves and mine aluminum and smelt it into mirrors, and I'd be surprised if we didn't have that capacity in this century, at which point you just designated a handful of asteroids or drop it on Mercury and tell it to get busy making copies of itself and stacks of aluminum foil. Ignoring that you could put pretty minimal guidance on those mirrors to let them all rotate and flicker in a coordinated pattern, turning your entire star into a big flickering lighthouse any primitive species with eyeballs would notice, you could take a minuscule fraction of that power, dump it into big radio transmitters, and still emit some 100 trillion megawatt slow pulse radio signal anyone in the galaxy could pick up and recognize as artificial even on very simple radios, and through pretty much any sort of noise and distortion you'd generally expect even over that much space. No one appears to be doing that though, from which we can conclude one of a few various things. The first of course is that they might not exist, either never existed or they died off before they can do this for some reason, like being eaten by their self-replicating machines and turned into solar mirrors or paperclips. Second, they don't want to do that big transmitter even though they could. Third, they could, but they have a better option. Or fourth, that they are just really frugal with their energy and value it more than early contact. They figure they can just wait an extra century till our telescopes can easily pick up weaker signals, or spot laser transmissions to us at low total energy per broadcast. Now the first impulse is to say that if they are chatty, especially given signal lag times, that they want to chat as soon as possible, but that doesn't mean they'd opt to do mega loud radio over lasers. After all, if time is everything, they can flicker that star visually, or just send a probe and be heard by primitives. That kind of energy expenditure, hundreds of trillions of megawatts for presumably thousands of years, is way more energy than you need to send out whole armadas of relativistic spaceships via light or laser propulsion. Alternatively, if they're frugal, well that's when we get into the notion of laser communications or laser SETI, the notion that they just send a relatively tight beam, be it in the microwave radio band or the optical, instead of something omnidirectional and way weaker at the receiving end than the tight beam would be. Frugality might matter too because everyone has a budget, and while it's likely a decent chunk of their population would be in favor of reaching out, odds are good most would not particularly care, especially in the context of potentially transmitting indefinitely. For context, back when SETI was getting government funding, it was to the tune of several $1 million a year. Not chump change, but that was around a 10 millionth of the global GDP, and that got pruned for budgetary reasons fairly quickly. If a K2 civilization was doing something parallel in terms of its total energy budget, then we'd be talking about a transmission power probably around 10 to 19 watts or 10 trillion megawatts. That's still a signal you can pick up galaxy-wide as an omnidirectional broadcast without needing super sensitive giant dishes, but someone is going to look at that budgetary item, nearly 1,000,000 times the power our whole civilization uses right now, and pointedly ask if they'd be better off just using a lot of telescopes and computers to determine where all the plausibly habitable planets are and where they would be when a signal might reach them, and tell the folks doing SETI to just use a bunch of lower power directed signals at all those places. This to me is the nail in the coffin of the omnidirectional approach. It doesn't matter that they have the power for massive omnidirectional perpetual signaling, they won't bother doing it, not to us and not to themselves either. It wastes power and generates noise. This of course raised the notion of using lasers instead of omnidirectional signaling, right Nick?
Absolutely right, Isaac. And on our channels, Alberto and I will be discussing the rise of laser SETI, both the search for laser signals from beyond, and employing them ourselves to broadcast to the universe. After decades of radio, we're finally coming round to the idea of optical lasers as an effective mode of ET communication, because they are so economical. They provide the most bright for your buck, so to speak. A single nanosecond pulse can outshine a star by 1,000 times, and require just 20 kilowatts of power. Obviously, we would be assuming that these entities would possess some technology, but given that the margins of error involved in the ages of extraterrestrial civilizations can run to millions of years, it doesn't seem much of a stretch to assume that they made the leap from radio to optical. And given that any transmission would take hundreds or even thousands of years just to be heard, it's fair to assume they've either crossed that particular civilizational line, or they're dead.
Indeed, thanks Nick. The thing is, you probably only bother transmitting like this if intelligent life is pretty rare and you want to talk to it. If high-tech civilizations are a dime a dozen, and millions develop independently in any given galaxy, you are going to know about that long before you're contemplating giant trillion megawatt radio transmitters, because it's equally easy to build giant radio receivers and pick up on all that chatter. If that's the case, you would have a focus on talking to those friendly and more advanced, or at least talkative and more advanced civilizations first, and would tend to expect them to be investigating wars nearer to them than to you and can just ask for updates. Alternatively, if intelligent life is so rare in frequency or duration that you need to shout across half the galaxy to be heard by one, then you might determine that this is because they don't last long in many cases, because they discover some very dangerous technology that's very attractive and not obviously dangerous, what we call a suicide pact technology. They might feel some haste was justified in contacting us, to for instance send out a message that said, "Whatever you do, do not experiment or use technology X, it will get you killed." And obviously it hopes to send that out as soon as they can hear it, before they play with Technology X and blow their planet up or get turned into paperclips. Of course, talkative does not necessarily mean friendly. They might just really want to sell you a subscription to Galactinet. Or they might be very hostile, and the message says, "Hey guys, here's the blueprint for a lot of cool technologies. We especially recommend Technology X." Now, what would such a signal actually look like in terms of content? Math is assumed to be more or less universal, so that's your first step for gaining notice. You repeat some series of numbers that is recognizably a pattern, and so improbable to occur naturally, that the odds of it ever doing so even once the entire duration of the universe is unlikely. That's not really tricky. You parse out the first 1,000 prime numbers in binary, then the first 1,000 digits of pi in binary, then the first 1,000 perfect squares in binary, and even the most extreme skeptic is going to say, yeah, that is artificial. That is likely to be a universally recognized message too, and it tells you 4 things for sure. First, someone is transmitting. Second, that they are trying to get your attention. Third, roughly where you should be looking. And fourth, that binary and math is going to be the basic language. Essentially it is a big look at me, I'm trying to say something. But it also tells you a 5th thing, that this signal is not the actual message. It's just telling you to look that way for it, because it contains nothing, and very clearly so. You are obviously not trying to inform folks who invented radio or telescopes what basic math is, so either the message is contained in that transmission to be decoded, or is just, stay here, there is more info, and they can hunt for a second transmission containing less easily recognizable but more informative information, the equivalent of a Rosetta Stone or explanation for building a GalactiNet receiver or so on. We discussed this in more detail in our episode Cryptic Aliens, but even with little to go on, an intelligent and curious mind, prerequisites for technology, is going to be able to make educated guesses even with no shared culture or biology about fairly abstract concepts. As an example, if you emit a specific pulse or pattern once in Earth Day, it's not hard for an alien to guess that is our day length. If you are doing precision beaming to planets, you probably have telescopes to see their planet, and know their day length and include a similar pulse at their day length. You could then do a pulse that had the same number of peaks as your year in days and vice versa theirs. That tells them your day length and year length, and also tells them you're trying to talk about time, and it also tells them, "We can see you, specifically you," which is a pretty good way to nudge them into replying if they're on the fence about the dangers of doing so, since you are pointing a finger at their face. This is yet another reason why laser SETI is probably a better approach. To explain why, here's Alberto from the Exoplanets channel.
Thank you very much, Isaac, for having me on your episode. Indeed, laser SETI lets you target your message. It is also, as Isaac discussed in Cryptic Aliens, way easier to crack a language when you have the equivalent of an entire library of data and massive computers to sort through for patterns. One of the examples there was that if someone is looking through a decade of our early radio transmissions, they are going to notice that words, or signal waveforms anyway, of certain types tended to be of very high density at certain times, like the words morning and evening, Tuesday and Thursday, January and August, etc.
Thanks, Alberto. We'll see you over in part 2 on the Exoplanets channel. Now, a computer can help you pick that sort of thing out, and is another reason you might decide to use communication techniques that were a bit more advanced to detect than massively loud omnidirectional radio chatter, because you know they'll have pretty decent computers to help with this sort of decoding and translation by that point. Folks talk about not being able to decode even human languages, but context matters. Those ancient mysterious tongues suffer from us only having a handful of examples written over large chunks of space and time. Languages mutate a lot, especially without dictionaries, so some loosely knit kingdom that existed for a few centuries and for which you only have maybe a dozen examples of writing that they left behind, and maybe a paragraph in length from a dozen different authors, all from different towns and different generations, does not lend itself to this sort of brute force cracking ability. Alternatively, if you got the big look at me transmission, and a second that is just a repeating sequence of core concepts like time or physical constants, or chemical formulas for simple and common stuff, and then a third with several terabytes of information repeating less frequently, you've got a good chance that they got the ability to receive that, and the computational capacity to hack that data, that they will figure out your language, and this is a great task for using lasers. And now you can talk. As to what you say, well, hopefully it is hello, we look forward to a friendly and mutually beneficial relationship. Here are some handy diagrams for useful technologies as a show of friendship and good faith. And hopefully it doesn't include a diagram for one of those suicide pact technologies we mentioned. A laser signal is probably a lot cheaper than sending armadas, plus all your neighbors know what you're saying if you're sending a big omnidirectional signal. If it's a tight comm beam, then they don't know what you sent, and would have to be watching carefully to see any scatter indicating you sent anything, so you can't be accused in front of the Galactic Tribunal of wiping out new civilizations. Again, talkative doesn't necessarily mean friendly. So we were talking about listening for signals today, and the difficulty of picking out signals from the noise, and if you've used many Bluetooth headsets or earbuds, you know how often it can be hard to hear them in a crowd. If you're looking for a good pair of earbuds with noise isolating features, I'd recommend trying out Raycon's Everyday E25 earbuds. They fit in snugly and discreetly for a noise isolating fit, so you can hear them even in a crowd. Plus they've got a good battery life and a very compact charging case with its own battery that can recharge them 4 times while you're on the go. So if you're looking for a good pair of premium earbuds, and at about half the price of other premium earbuds, try out Raycon. Raycon was founded by Ray J and is a favorite of folks like Snoop Dogg and Melissa Etheridge for their wide range of stylish and fun colors and super comfortable fits. And if you'd like to give them a try, you can get 15% off today. Just use the link in the episode's description, buyraycon.com/IsaacArthur. So we were looking at aliens trying to talk to us today, and we'll be exploring that more in parts 2 and 3 with Alberto and Nick, linked to the episode description and the in-video cards. And we saw today that advanced civilizations have means of transmitting galaxy-wide if they want to, but so far we're not seeing them. In parts 2 and 3 we will examine laser SETI, and ask if maybe we're just not looking hard enough in the right place. But one alternative is that no one is transmitting inside the galaxy, and one possible reason for that may be that there was some massive galactic disaster that either wiped out civilizations or prevented anyone arising before us, and we'll be exploring that notion more this Thursday in The Fermi Paradox: Galactic Disasters. Of course, another option is that their civilization got to our point and just collapsed, and a lot of reasons get suggested for that, but one is that their governments just are not able to handle expansion into space and the wider galaxy, and we'll explore some future types of government on Thursday, August 27th. Then 2 weeks from now, we'll close out August with our monthly livestream Q&A on Sunday, August 30th, 4 PM Eastern US time. I hope to see you there, and don't forget to bring your questions. For alerts when those and other episodes come out, don't forget to subscribe to the channel, and don't forget to hop over to Alberto and Nick's channels for parts 2 and 3, and hit the like and subscribe buttons there while you're at it. Until next time, thanks for watching, and have a great week.